Hey, and welcome gurus to this demo lesson, Implement Traffic Manager. I'm Chase, and in this demo lesson, we're going to start off by using our case study scenario to be able to understand what is going to be inside the Azure Cloud Sandbox when we start off with this demonstration. And then we're going to go through our demo steps on what we will do to implement Traffic Manager inside the Azure Cloud Sandbox, and then we'll bring it back to the slides to wrap up with some key takeaways. So to get started with our Control-Alt-Suites organization, we have our all too familiar Hub Virtual Network. And this time inside of it, we have an app service, and that is our Hub App Service. Then we have our Spoke Virtual Network, and this has our Spoke App Service inside of it. And each of these are going to be in different regions entirely. So we're going to have one in East US and another in West US. And this is going to be what we see when we get into the Azure Cloud Sandbox. Now, as always, the setup for the demonstration is available in the resources of this lesson. The demo steps that we will go through once we set up our environment is implement Traffic Manager by creating a Traffic Manager profile and configuring those app services as endpoints, and then we're going to configure the routing for both of those by specifying the performance-based routing method. And then we're going to configure that endpoint monitoring for HTTP settings and health probe settings so that we can see how we can tweak that endpoint monitoring for those endpoints. And then we're going to review our configuration and discuss our thoughts on our options and how we might make this solution production ready. All right, gurus, without further ado, let's make our way into the Azure portal and get started. All right, gurus, here we are in the Azure portal in our Cloud Sandbox. And to get started setting up our demo, we'll go to the resources of this lesson, get our resources file, we'll copy everything down here, and we'll bring it down into our Cloud Shell, paste it into our Cloud Shell, and what this is going to do is go off and deploy all those resources that we need to get started. It's going to include 2 virtual networks, a hub and spoke virtual network, and in each of those virtual networks, we're going to have a web application using app service running. So we'll be back in about 10 to 15 minutes once this is complete. All right, gurus, so we're back and our resources have finished deploying. So we'll minimize our Cloud Shell here and we'll refresh. We'll close up the Essentials tab there, sort by type, and we'll see we got those 2 app services. We see they're in 2 different regions in this case. So we have the Hub Web App and the Spoke Web App. And what we're going to do real fast is just browse to them to see how they're different. We'll click on the URL, and right now we're looking at the Hub Web App. And then while that's loading, we're going to go back to the resource group, click on the Spoke Web App, and we'll open up that URL as well. Click on it, go back to the hub, and we see it says hello from the hub region. And then here we see hello from the Spoke region. All right, we'll close those up. We know they're both working. We'll go back to our resource group. And now what we're going to do is we're going to implement our Traffic Manager. First thing we need to do, come up to the search bar, type in Traffic Manager, select Traffic Manager Profiles under Services, and click Create. And then we're going to configure our Traffic Manager here. We'll minimize that portion of the blade. We'll give it a name here. Again, this has to be globally unique. Call mine Cloud Chase, and it'll be cloudchase.trafficmanager.net. And then we'll choose our routing method here. And in this case, I'm going to use the performance-based routing, and then it pre-selects our subscription. We'll select our resource group, and we'll click Create here, and it's going to go off and create that Traffic Manager profile for us. Now, we'll be back once this is done in a few minutes. All right, gurus, so we're back, and it's not readily apparent that our Traffic Manager is successfully deployed unless you were to hit refresh here and see that resource, or if you were to check the notifications and see that the activity log shows the deployment succeeded. It doesn't take us to a new page like a lot of resource deployments. So now it's done. We'll click into it here, and we see we have our DNS name. Now we need to look at the configuration here. Under the configuration, we see we can alter our routing methods after the fact. We could change it to whatever it is we like here, from performance, weighted, priority, geographic, multi-value, or subnet. We're going to leave it at performance here, and we also see we can set our DNS TTL, and it's set based on seconds. And then we see that endpoint monitoring settings that we talked about here. We have HTTP, we have HTTPS and TCP. We can specify our port here. We're going to leave it at HTTP and port 80. We can specify our path that we're going to be probing. We'll leave it at the default /. And then we have our custom header settings. Using these custom header settings, we can configure those custom headers in a format that looks like host, contoso.com, new header, new value, and you can see that right there in the information bubble. But we can configure these and we can have multiple pairings. We can have up to 8 pairings specifically, and it's applicable for HTTP and HTTPS protocol. And it will be applicable for all the endpoints that are inside of this Traffic Manager profile. Now we don't need to set any here, and then we also see we can set the expected status code ranges, and the default's going to be 200. We'll leave it at 200 because we're just looking to make sure that it responds. And then we see we have our fast endpoint failover settings. So here we can configure the time interval between health probes here, and it's going to be 30 or 10. We could select 10 here, and then we can say how many tolerated number of failures we want. And it could be 0 to 9. We'll say we want 1, and then we have our probe timeout, and this value can be between 5 and 9. Let's say we want it to be 5. And this means basically we're going to probe every 10 seconds, and if we get 1 failure, we're going to do the failover. So we're going to click Save for these settings. We changed our configuration, and we set up that HTTP endpoint monitoring for our Traffic Manager profile. And then we'll come down here to our endpoints. Now we don't have any endpoints, so we're going to add those app services. We'll click Add, and then we see we have our types. We have Azure Endpoint, External, and Nested. With Azure here, we see we can select Cloud Service, App Service Slot, Public IP address. With our external, we see we can provide a FQDN or an IP. And then for our nested endpoint, we see we can select whatever Traffic Manager profiles we have. We see, of course, the one that we have created. So we couldn't nest, obviously, this one inside of itself. But if we had another one, we could nest it in there. And that's how we can actually set up to use multiple routing methods in unison by having nested Traffic Manager profiles. So we're going to use an Azure endpoint here, and we're going to give it a name. We'll call this our Hub App, and we'll select our app service, and then we'll select Hub Web App, and then we're going to click Add. And as soon as this is done, what we're going to do is add the other one for our Spoke. Now it's there, we'll click Add. We'll leave Azure Endpoint selected. We'll call this our Spoke App. We'll select App Service. We'll choose our Spoke Web App, and we'll click Add here. And this is going to add that. And we'll have both of these now as endpoints for our Traffic Manager profile. So we see they're both there. Now at this point, what we're going to do, go to our overview, grab that DNS name, copy it, bring it up to the browser, paste it into our tab, hit enter, and we see it says hello from the Spoke region. And the reason it's returning this Spoke region to me versus the Hub region is because the Traffic Manager profile has decided that this region where the Spoke web app is going to provide me the lowest latency. So therefore it has the best performance, and that's why it's serving my traffic there. You may get a different one when you do this, just based off of where you are in the world. All right, gurus, let's head back to our portal real fast, take a look at some of the other settings we have here. As we see with Traffic Manager, we can also take a look at the real user measurements. And this is where we can generate a key and embed the provided code in the web property to send network latency measurements from our web client to Azure Traffic Manager. We also have a traffic viewer. We can enable this to view the location, the volume, and the latency information for connections between users and the Traffic Manager endpoints that we have. And also, of course, as all resources, we can set up diagnostic settings and do metrics and alerting. All right, gurus, we successfully set up this Traffic Manager profile, and we are balancing traffic based on DNS between these app services. Now let's make our way back to the slides for a quick review of this lesson. All right, gurus, congratulations on following along in this demonstration of implementing Traffic Manager profile for those 2 web app services. Now, one of the key takeaways for us to remember, as always, with Traffic Manager is those routing methods, right? We could have used priority, where we could have prioritized one as a primary and one as a backend endpoint. We could have weighted these to distribute traffic according to the weight value that we set. We could have done performance, which is what we actually did in the demonstration, to send traffic to just the closest endpoint that's going to provide the best performance and lowest latency. We could use geographic to route traffic based on geographic location of the client. We could have used multi-value to return both endpoints to the request, and it would have just picked one. Then we also could have used the subnet to route traffic based on the requester's IP address. We didn't do that one, obviously, because it's a little bit difficult for us to grab our IP address and do that every time. So we chose the performance-based. Now, the purpose of Traffic Manager, as we saw in this demonstration, is to perform that layer 7 DNS-based load balancing for us at a global scale. As we saw, by balancing to Azure endpoints, specifically our app services, in different regions. Now, if we wanted to, we could have balanced to on-premise endpoints that are external to Azure, and we could have also balanced to nested endpoints if we had multiple Traffic Manager profiles so that we could stack multiple routing methods together. All right, gurus, that is all my time for now. Thanks so much for joining me in this demonstration, and I look forward to seeing you in the next lesson.